Okay, so we are getting ready here. How's it going,
So
Ted?
both of you guys are going to be in the picture?
Yeah. You want to introduce yourself?
I'm the bad moderator for MUFON.
Be serious.
Glenn Green.
I can't do anything right.
Come on, live long and prosper. What's this? What's this mean?
This
War, victory?
So let's see what you want.
So you hold it from the right hand like this.
Mm-hmm.
It's recording right now. The only thing you got to worry about is this button. This zooms in and out, okay?
You just keep it recording. You got it.
Watch behind you there.
The weight.
And always watch the screen. The screen can tilt. So if you want different angles, so it might be useful to come from up above or down below. Just always look at the screen.
I might use this to go up a little bit.
Yeah, just always look at the screen. And the screen tilts. So tilt.
Yeah.
Okay.
And if I may suggest, don't pan real fast.
Yes.
You know, that's annoying when we see it later.
Yeah, you want to avoid that. Okay, you ready?
Yes?
Yeah, go. Just drop it in. Okay, there we go.
You got all this?
Yep.
Okay.
And this one, all of that like that. Still wants to move a little further along. Okay.
An introduction, just a second.
Introduce. Oh, zoom in on his work.
Hi, it's Ted Pittman here with Mark Sokol. There's Mark Sokol. Well, ignore that. Falcon Space Labs. Today is February 17th, 2023. And we're testing the gravity diode, formerly the Gamma Max engine. And
we're ignoring the cell phone.
the world is trying to reach us even as we speak.
Can you just shut it off, maybe?
Yeah, we can start off.
It seems like it's gonna keep on going.
Shut it down.
Yeah, I'm shut down. Way down too. Okay, take two. Hey guys, we're here at the Falcon Space Lab with Ted Pittman working on the Gamma Drive. Can you explain that?
And Mark Sokol.
And
Also,
me, of course.
Also the co-inventor of the gravity diode. What you're about to see is a counterweight test, similar to earlier tests that are on YouTube. And the point here is that we have basically 4 impulse drivers. All of the machines of this family in the past have been just one cylinder, as we call it. It's all explained on YouTube. You can search Nate Lachey and see 17 videos, and this is the culmination of years of work since 2013 at least.
So Ted's contribution to this device is the reaction engine itself. There's 4 of them. My contribution is the method in which we assembled all of them together and have them counter-rotating, all running off of 2 motors. So that would be the X-frame design with the ribbons as well, and the bobbins. There was a lot of manufacturing genius that went into this,
Yes.
and a lot of junk, scrap parts that came out of this project until we finally got it to this point.
And let me interrupt. When he says manufacturing genius that went into this machine that you see here, excuse me, was intended to have 2, 4, 6, 8 electric motors running it. Mark turned it down to just 2.
Yeah, and it makes it a lot more efficient, a lot easier to run, and also a lot lighter too. So we have the whole thing on a balance over here. You can just zoom out, and you all can see that there's a balance, and it can move left and right. So we have a gyroscope machine that's going to be rotating on a balance. And Ted, do you want to do the?
Well, just before we start, I'd like to state clearly now that the work that you see here is not anti-gravity. It's not intended to be anti-gravity. It's gravity-assisted propulsion.
Okay, very cool. So in order to run this thing, I'm going to have this controller in my hand in case we need a sudden shutdown.
One of us needs to read it off and the other will turn the knobs. All right.
Oh,
This is for upper. This is for lower.
I guess you can just leave that over here. But what's important is what numbers we're reaching. So you want to get the angle from here to see these numbers. You see that right now it's 0, 1, 0, 2, and then it would flip to 1, 0. So these numbers over here represent, it's basically a 10-turn pot, and it has 100 different segments. This is what's controlling the speed of the stepper motors, and we have two stepper motors over here: the bottom one, the lower one, and the upper one. Lower one controls this swivel arm. The top one controls the rotation of this universal coupling, which turns this around. So these gyroscopes, or complex masses, are actually rotating on 3 different axes. You have this one, which is an axis of rotation, this over here, which is an axis of rotation, and then the flip itself, where it can flip over or pivot, that is another axis of rotation. And it's only when we get the third axis of rotation, the pivot, flipping over, that we are expecting to see any effects. Now, from past reference, you have these numbers written down, which represented the pot values when we started to see pivoting. It won't necessarily be the same in this case because we're missing components that were there before, and we added components that aren't here. So let's just see on those values exactly what ends up happening. Are you ready?
Okay. For a start, we'll just test the motors to make sure they rotate. Upper motor only.
I think we have the bottom motor going too, but
Okay, we're concerned with the upper motor at this point.
yeah, you're
I'm
bringing
going to
it.
set it to 1.64.
It seems to be running pretty well.
Okay, this is the actual setting that we're going to run at when we're at full speed. Upper motor is successfully moving without any problems. I'll shut it down.
Now the lower motor has been the problem.
Lower motor by itself.
The lower motor has a lot more movement to it.
Now at 1.0, and the goal might be 6.6. I say might because we'll stop if we run into trouble before we reach that value. Lower motor now is at 2.0.
I suggest if you're going to go for full speed on the lower motor, 6.6, you get the top motor at full speed.
First.
Yeah, just get it there because it's a lot easier to reach.
Then we want to see the lower motor make it all the way to its...
It's never made it.
Well, that's what we need to see without the top motor interfering.
No, the top motor doesn't interfere. It barely does anything. Well, it's almost pivoting now, is it? Look at that. Oh no, it's just wobbling.
All right, we'll do it the way we did last time, like you said.
Here you go.
Lower motor is down, upper motor is down. We're going to bring the upper motor up to its operational speed for resonance. 1.64 is the goal.
Okay.
We're at 1.64.
Oh, one second. I'm going to stop you there. I see a pin coming out here. Pair of pliers. Try to push that back in. Technical difficulties. This is very common on this device. There are so many moving parts on this thing, it's amazing that it holds together. This is loose too. Okay, we may need to, let's see, yeah, this is a bit loose. Think it'll hold?
I can't see what you're seeing.
The brass, oh yeah, this one too. The brass is loose against the aluminum. Is that a big problem?
Okay, we should pause.
No, we'll continue videoing.
No, I want to go to tighten this.
Yeah, we got
Phillips. Small Phillips or just Phillips?
Oh, for that you need the Phillips on the 90. What do you got? I don't see it. A little. Oh, there it is. Here it is. Yeah. I call this the Phillips on the 90. 90. Maybe this one. Ooh. No. Even this doesn't fit. Even that doesn't fit. No, there's nothing that fits in there. I can just tighten it by hand. I managed to tighten it all up by hand. Yeah, that might work. I want a slightly larger screwdriver.
I think it is as tight as it's going to get, actually.
Yeah. Yeah, I was able to tighten it a little bit by hand. Okay. Are we ready to resume?
Okay. Upper motor will start at 164.
Okay. Okay, you can start speeding up the lower motor.
Lower motor is now at 1.0, 1.5, 2.0,
Wait.
holding at 2.0.
I paused it. This whole thing is coming off. The upper motor. That whole setup is coming off right now.
Yes.
Yeah, the whole thing came off. It needs a way to hold down.
Isn't this holding it?
No, because we removed the part below it. It was just pulling out from the bottom.
So it was riding upward?
Yeah, it was riding upward. It was about to fall off.
Put the front back on the bottom.
No, and that destroys it. What?
Push stop.
Yeah, just push stop. No,
Where's stop?
no, this is the stop right there.
Okay.
You
Can
have
I
to push
push that to start it again, too?
Yeah, you
Okay,
just push it.
so you want me to just pause for now?
Yeah, sure, pause.
Okay.
Push that button. Just push it. No, this one. This is the control from the right hand. You ready? Okay. Take two. We just did a little bit of a repair here. And do you want to turn the numbers down before I power up?
We'll power up with upper at 1.64.
And lower at?
0. To
Okay.
start.
It's powering.
Okay, we're bringing the lower up now. 0.5. 1.0. 1.5. 2.0. 2.5. 3.0. 3.5.
10, I don't think you need it. You have glasses on. Sorry.
4.0 on the lower. 4.5. 5.0. You got the stop button, Mark?
Yeah.
5.2. 5.5. 6.0. No inversion yet?
No, it's slipping.
Okay, we probably started at the wrong position.
No, something was slipping there.
Okay, lower motor's all the way down. We didn't check the starting position.
Doesn't starting position only matter if you're going full speed immediately?
No, because it's a stepper motor. Whether you go fast or slow, it's a certain number of steps to get you to a certain speed.
Okay, I think I see the problem here. This is starting to hit over here because whatever this distance is, it expands it somehow. Okay, that's a Phillips screwdriver right
You
here.
still running?
Turn it off. Don't turn it off until you run out of space. It should be good for like 8 hours. I need a different screwdriver.
Bigger?
No, I need a
What?
Phillips.
Small?
No, large Phillips.
Look at my toolbox, second drawer down.
Okay, large Phillips here. Okay, I think we fixed that
Okay,
problem.
hang on. We got the alignment here, but we don't have it here. This should be tangent. This is good here. That's about it. All right.
Is that good?
Yeah.
Okay, tell me when you're ready to start.
Okay, camera's on. Hello.
Yes, the camera's on.
All right, we're starting at
You know how to use the zoom, right?
Yeah,
How do you
right
use
up
it?
here.
How do you use it?
Either forward or back.
How do you use it? Let me see you use it.
This one.
Yeah. Yeah, there you go. And don't keep your finger on the trigger button because you might trigger it. Turn it off.
Right.
Okay, you ready? Okay, 3, 2, 1, power on.
upper is at 1.64. Lower is starting now. Lower motor is at 1.0. 1.5. 2.0. 2.5. 3.0. 3.5. 4.0. 4.5. Inverting?
Nope, not yet.
5.0. 5.5. 5.7.
It was doing shit again.
6.0.
It started to It looks like we have a similar problem here
It didn't
again.
invert at any point?
No. Something's happening on this one again. It's getting like pushed down into it. Yeah, so we had a little mechanical problem here. Yeah, just don't stop until I tell you to stop.
Okay.
Maybe one of those clamps would be better to work. The big clamps.
Fine right here.
Wonderful.
That's tight enough right here. Get a little bit of pinkies here on it now. Well, there's a problem. Didn't line it up properly.
Well, once you loosen it, let's line up the other three.
Well, the other three are lined up. It's this one that needs to change position. Are they lined up? One second, was that moving along? How is that happening? You have to tighten it there.
Too small. Oh, no, not too small.
That's the right size because I just used it.
This is good.
There's a lot of play there. You okay with
Where?
that? See there?
On the bottom?
Yeah, on the bottom, on the top. Depends where you move it to.
I can live with that.
Okay, let's see if the machine can live with it. Are we ready to go again?
Hang on. Alright. The gap in your rotors should be pointing towards here. Right. Okay.
You ready? 3, 2, 1.
Camera on?
Yup. It's been
Camera
on.
should never turn off.
It's been on.
Okay, power please.
Yeah.
Upper motor's at 1.64 already. Lower motor at 0. Coming up. Lower motor's at 1.0. Lower motor's at 2.0. 3.0. 3.5. 4.0. 4.5. 5.0.
Former RAF radar technician.
5.5. 6.0.
So what happened was the bottom rotor just didn't reach speed. It started to shake, something like vibrate, and
Could you see the vibration?
the vibration was from the motor
Oh.
not having enough torque to turn it.
When this came off, what did you see? Anything?
That just came. That's when it was turning pretty slowly. It basically reaches a point where the speed of the motor and the speed of the rotation of the magnetic fields and the speed of that it's actually getting to turn is not the same.
Friction?
Too much friction. Yeah, there's too much friction in the lower system. That's the issue. So we
Do you think we need a more powerful motor?
either that, yeah. You know, we
I've
need-
looked one up from another manufacturer that would fit. This frame is a NE, I think 34, something like that, this frame. I found one that has the same frame and a higher torque rating. I brought the plots, you can see it. It seemed to be like maybe 10-15% more torque.
That should do it then. That's what we need to do. Because we can replay the video here. You can see what, as soon as it starts making that humming sound, as if that's when the speed, the RPM that's being produced drops even while you're asking for more power.
Alright. You got the power off here.
Yeah, now it's double off. Okay, well, there's what happened with that last test. Unfortunately, the device
That's too much friction.
has too much friction. Is there any way we can test this though with a slower top motor? Like the top motor speed, the upper motor. Well, we could lower that from 1.6 down to 1, and maybe have 1 and 5.
Oh, a different resonance zone. There are different resonance zones. I'd have to do the math to see, because I didn't even calculate for the changes we've already made. These numbers are from the previous physical size of everything.
Right. So we are making it safely into the
Resonance zone.
into the 5.5 on the lower motor. I think that's about where we made it to. Maybe
Well,
5.
yeah, but 6.6 is.
I know, but we're not going to get there with this
Yeah.
motor. The question is if we push the lower motor to its limit, which is about 5, can we just play with the upper motor then and see if there's a resonance point there?
The answer is yes, but it looks like from every option that we're discussing, we still need a more powerful lower motor.
Yeah. Well, this is something that we could test right now. That's the point. Before changing out the motor, let's try out the lower motor's limit. We already know what its limit is. The question is if we can get a resonance at that limit. Oh, and while we're at it, this is loose. Let's tighten this up. Here, can you tighten that up? We need these purifiers.
Do we still need the camera?
Yes, we do. The camera is very important. It's the only way we
There's no
know.
Loctite on this.
That's what I'm putting Loctite on it right now. Oh, Loctite. Let me see if it's coming out. Ooh. Enough?
Mm-hmm.
Magic Loctite. Oh, you have to do the little clicky thing there. You love that little tool?
Oh. Okay.
It's good?
Yeah, the hole is deeper than the screw.
Oh, they're both threaded, I see.
Yeah.
Actually,
No, you can go too far.
yeah, I know. I'm pulling it out.
Oh.
Because they need to be lined up perfectly when you first put them in.
They are.
No, they're not. No, they are. Let's see if it'll grab it though in that position.
You squeezing?
Yeah, I'm squeezing. No, they can't grab it in that position.
I had put the two pieces in a vise the first time I did it here.
Mm-hmm. Okay. Just so you know, when we were running this before, last time I had somebody here, we had GoPro cameras up on the top with power supplies to them. They would run every single day, the entire time we were working at the lab. That's how I have so much footage. We love our footage. Never have too much. Although that becomes quite a challenge to edit. Ooh, yeah. This is good. I'm gonna put Loctite on this pin too. He's thirsty. Glenn, you could pan around. You know, you could get Pinky in the shot too. Make it interesting. Show everyone what's going on. Okay, I think we're kind of ready here.
All right, we can try.
Oh, look at that. So you got here. You got to stand up and get over his shoulder. That's the right angle.
Okay.
Like this. Here. You can see both him and the angle. See?
All right, we'll try 0.82 upper and
Zoom in on the thing he's showing you too.
5.78 on the lower.
Which one is that?
This is from successful test GM076,
Zoom in. Zoom in.
June 25th, 2018.
Zoom in. Zoom in.
Reported here success. The pivot signal was at resonance.
Back out.
The ratio this time,
Way too much. Back out.
the significant thing about the speeds now
Okay.
that you're asking for, Mark, the ratio instead of being 8-to-1 will be 7-to-1.
Okay.
Wait a minute.
Zoom out. Zoom out slowly. No, zoom out. He's using. You can use it. You have to control it. Like with this thing, you have to. So you can control the speed that it zooms out. Just keep your finger on it. And it's like a game controller. Mm-hmm. Like a joystick.
Okay, you got it.
Okay. Okay, let's play now. You ready to start?
No. All right. Oh, ratio is 7.
So what are the end numbers that we're going for?
Upper is 0.82, lower is 5.78.
Ah, okay.
Oh.
5, 7, 8.
Well, let me see if I can get it down more.
I don't know if we'll reach size 7, 8. Be gentle with the zoom. Don't jerk it. Slow and steady.
Well, this is all the way down. We can try it at 2.25. Was a successful test. 2.25. Upper, is it upper or lower? Upper. 2.25.
How about we do this? How about we just get the bottom going at 5 and then play with the top?
One thing at a time, one thing at a time.
Because these numbers might not be relevant because it's a different machine.
But the ratio is, well, yeah. Let's just see what we got. This idea was good 5 minutes ago. Let's try it. You ready? 2.25 for upper. Yeah.
And what for lower?
This is going to be 2.5 to 1. Lower is at 5.8. Oh, it's still not where we want to be.
How about we just do the bottom at 5 and move the top around because we can't go past 5. Pinky showing interest in it.
We can play around like that, Mark, but I don't think we're going to gain anything. It'll just be pure luck.
That's what we need at this point.
All of the ones at the lower speeds had problems.
Okay.
I understand what you're saying and how you feel, but it'll just be luck if we find the right ratio of speeds here that makes this thing move. We could spend days. Seriously. It's not just a linear thing, you know, you change this number twice and take that number twice and you get half the... It's not like that.
I mean, we have an hour, so let's do it for an hour. Keep it running for an hour. Let's see what happens. Okay? Let's go. You ready?
No.
I don't think this thing will run for days. So, the other option is changing out the motor.
Yeah.
But that can wait because we don't have that motor. Let's first push this motor to the limit. There's no
We're
reason
pushing
not
all
to.
the other parts to the limit also. Not to the limit, but we're pushing all the other parts.
Nowhere near as much as you want to push them more with the new motor.
The parts that are good right now, we should just leave them alone. If we start running and everything, what else is going to fall apart and so on? That's been our history so far.
Oh yeah, it continually falls apart. And we're running it at 5 and you're trying to run it at 7.
Yeah, yeah.
So let's just run it at 5 for a while, see what breaks, see if we can get it to work at 5, and then we'll know what to do in order to get ready for 7, okay?
I don't think we'll know anything after that except what doesn't work.
Yeah, that's what we need to know. We need to know what will break, and we need to know if a resonance can be found at the limits of this motor.
We can run it for a while.
Yeah. Okay, what settings do you have now?
Well, they're all in the 5 range, greater than 5. Oh, here.
On the machine?
0.
0. Okay, so let's start it up.
Upper is still at 1.4.
Oh, so it's not 0. Okay, so set the upper at like half.
The screen came up.
Oh, just push X.
Okay. Thank you.
It's a touch screen.
Okay, let's get our starting position.
Yeah, off.
Yeah.
If you're able to do that, it means that it's not connected over here.
Oh, we've always started like this. Should have started out further.
Okay, there we go. What do you want to do?
Let me take the lower around. Yeah, exactly. Now tangent. This is tangent, this is tangent. Make that tangent.
Okay.
And that one tangent.
You ready?
No, hang on. Now that we're starting in this position, why not do what we just tried to do?
I don't know what you mean by do it.
Okay. The last time we tried to do a 100% run a few minutes ago, these were at the inner position. Now they're at the outer position for starting. So let's try a standard real test with the original numbers.
We're not going to reach the original numbers. You can only go up to 5 on the bottom before it starts breaking. We know that already. We've done that several times. That's what we're going to do. We're going to go to 5, not 5.5, and then we're just going to change the top.
All right.
If you do anything else, it's not going to work. We've done that twice already.
We'll give it a try.
Ready?
Where do you want the top to be?
You keep it at 0. Just get to 5 on the bottom first, and then slowly ramp up the top. And we'll see what happens.
Everything, camera on,
Yeah, it's going.
got power.
Mm-hmm.
Here we go. Lower motor at
You can just call it out like
1.0. I don't know.
Just call it out as 10. 10, 11, 12. This way we have more digits. What are we at?
2.0.
20, 21, 22. Can you just count it out?
25,
26.
30,
Every point. 31.
31, 32, 33, 34, 35, 36, 37, 39, 40, 41, 42, 43, 44. Sounds like it's flipping.
Yeah, it
45.
is flipping.
All of them? 46. I can't look. 47,
A lot of them are.
48, 49, 50.
Okay, stop right there.
Right at 50.
Okay, top one. Start moving the top one slowly. Upper.
0.4, 0.5,
5, 6.
7, 8, 9, 10, 11, 12.
The resonance is lower, so take it down to 6.
Say again?
6. Go back to 6.
Going back.
It's somewhere around 6.
I'm at 6 right now.
Yeah, this is about where it is. Take it out to 5. Just play around there. Between 5 and 7.
5.
Oh! Yeah, that's about where the resonance was.
Okay. 5 for lower and
50 for the top. It's a lot easier to say 5 than 0.5. That's what, getting rid of the point in your communication makes it easier. Yeah. This is something that's going to have to be redone. Well, one great thing about us getting a lathe, by the way, is that a lot of this stuff needs to be remade.
yeah,
And we're going to have a lathe to do it.
yeah.
And I'm really excited about that.
When would you expect it to be operational?
It'll be here Tuesday, and it should be operational Tuesday.
Mark Sokol. It'll be here in the morning, it'll be operating in the afternoon.
But I think I'm happy now with what we did. I do agree it probably needs to be a little bit faster. We did see some pivoting though.
I want to see that
Yeah, we're gonna have to play that back.
immediately. Like, I was looking down all the time.
Yeah, of course.
But you saw all 4 of them inverting?
Not at the same time. Like this one was inverting, that one was inverting.
Yeah. Because we had a real smooth run the last time. At least when they were starting up, everything was smooth coming up to speed.
Yeah, what happens is it reaches a point right around like 57, 58 or 57, 58 where you're turning it to go faster, but it can't keep up anymore. It just slows down. It starts going bzzz, it just because the magnetic fields are turning, but the rotor can't keep up with it anymore because it's like at the torque limit.
Okay.
That's what's happening. So as to the question that you asked me right in the beginning is, are these motors powerful enough? The answer is barely. For the upper, yes. For the lower, barely. Like maybe if we found a way to shed a couple of bits of resistance.
Yeah. Well, I got the.
It's not a lot of. There's not a lot of friction here. For what's going on, this is pretty good.
I got the torque charts and also mechanical drawings of the new motor. So can you look at that and see if it's going to fit before?
If it's the same casing, it should fit. And if it's a little taller, then we can machine this out, or we can make adjustments. Are you going to get 2 of them, one for the top and one for the bottom, or?
No, we had a bunch of motors for the top. We don't have a problem with the top.
Yeah, the top's never been a problem
Yeah.
because it's a lot less torque there.
Yeah.
But what we have been having problems with are these things. These all need to be thrown out, and we need to get new ones from the lathe.
Okay, I agree. And C-clamps here, just a C-clamp. Remember we were talking about the collar was too big, and we talked about that a lot and so on.
Oh no, that's going to be made on the lathe.
I understand. But for the bottom of this, to keep it in place from
That's
going
going to
out.
be made on the lathe. It's not going to be a clamp. It's going to be a physical piece of metal that's just larger from the hole. That's all it has to be.
Okay, I understand. A C-clamp would be thinner.
We don't want... No, it won't be. Is a C-clamp 1 millimeter thick?
I don't know.
C-clamps are thicker than 1 millimeter.
All right, so this problem will not be a problem anymore.
That hasn't been a problem this entire test run. The main problems we've been having have been the most of these joints going out of alignment. We've had screws,
Oh, set screws for sure. Yeah.
set screws and all that. We've had these things falling off. A lot of these problems are fixable with the lathe. Once we get a lathe in here.
You have all the drawings, and changing the motor is not a big deal.
If it's the same dimensions, it won't be a big deal at all. Cause
Think about
fit.
this. Can't we take your CAD drawings, put them on your magical machines, because that's what they like to see them see and so on, and make another whole machine more perfect than this? I mean, you just hit a button. You don't go with a file and a saw.
Yeah, we can make a whole bunch of these. How many do you want? 10? 100?
No. I mean, this was the first X-Bar one.
Yeah, but it hasn't worked yet, so I'm not making any more of them until we gotta get the motor so that it works properly, and then see if it's actually producing effect. That's the goal.
A stronger motor is a stronger motor. I mean,
Right. It's not reaching speeds, and your paperwork, basically, from your past tests said that there was no tests below 5 on the lower motor that worked.
right.
That means that our motor, sadly, isn't powerful enough for this.
Right.
thing.
We agree on that. But again,
So we can't consider this to be a failure at this point, just because it didn't produce a result because of that. So we have to continue, with the research that way.
what I'm suggesting is building another more perfect one doesn't seem like it would be a big deal. because of the
This
machines.
this one is pretty perfect right now. This one, the dimensions are pretty tight. We're getting very close.
Okay, take
to
out the word perfect. Building one that doesn't have any of the problems that we have seen. It doesn't look like...
It would have to use all of these parts though.
Yeah, but new. A
Well-
second machine.
Well, by new you want to get new.
Second machine.
You want to spend all the money to buy all the spare parts? Do you have more?
Well, no,
Advanced.
not a second belt and stuff like that.
So what part is new? I mean, we're gonna replace these. These need to be replaced. These bars over here need to get longer if we can find longer ones. These metal washers over here should be replaced with plastic. The stick.
Well, I'm not
things-
suggesting we throw out anything that's already working. I'm not suggesting that at all.
Oh, okay.
I
Yeah,
guess
yeah.
when I say
We'll
build
be
a new one, it
replacing
sounds
some.
like
We're replacing some parts, but 95% of it's going to be what's here. Yeah, not 95. Probably 80% of what's here is going to be reused at this point. Most of it is good.
I would like very much to see the design of the cylinders, let's call them, even though they're not encased, straight according to the pattern. That,
What do you mean, cutting off this part?
no, I'm saying straight according to the pattern. I got it in the drawings and so on. For 3 years, that design worked, Mark. It just worked. I mean, there were little problems and this and so on.
Okay, I mean, if you want to change this part over here, this bottom arm, that's, we could
Well,
do
it
that.
had the collar at the bottom and whatnot. You don't like the collar at the bottom, but so what? We put a collar at the bottom.
It'll hit and it'll destroy itself.
It didn't in the past.
That's because you had 2 bottom plates. No, you have 3 bottom plates. We only have 1. We don't have that luxury of that much space.
Let's just consider for a second bottom plate.
And the thing weighs a lot more, and
It weighs more, not necessarily a lot.
Okay, we can consider that. We also have the idea of cutting this plate, like getting 2 1/8-inch plates. That was another idea we talked about. And that's another consideration that could possibly work. But so long.
You realize no matter how heavy it is, if we put a counterweight over there, we can still prove the point that the thing is generating lift.
It's true, but it does get harder to see the heavier it gets. Yeah, we could do that. We could get like 2 1/8-inch plates, or maybe just put another 1/8-inch plate over here. Just that would allow you to move this up and
Okay,
down.
that's all I'm suggesting. Let's think about a new design. Not overall change. I did say build a second one as if ignore all this. I don't mean that. I just mean build one with the improvements built in that the problems we've been seeing cannot happen.
Of course, yeah, we're gonna do that. We're gonna do that. And I think one of the main things we need to do is replace all these bars. They all need to go. And
This bar here,
yeah, that stuff is shit.
what are you going to replace it with?
Something that we'll make on the lathe.
Okay. Yeah, so possibly 2 plates here and there.
Mm-hmm.
Hey, well, the top we don't have a problem with,
Right.
so leave the top alone.
Yep. Alrighty then. I think we can shut this down and put it away. And what do you say?
Can I get a copy of the video to take with me?
Oh, sure. Do you have a way to hold it?
Well, I got a thumb drive.
Okay, we'll put it on the thumb drive. Okay, you can shut it down, guys. Take care.
Over